I'm going to share with you the question that we have been given to solve, and then we will be discussing the answers for them soon. We can see here the solution, the values that we've been given is the allowable shear stress at the brass and the aluminum, which is 60 and 90 MPa respectively, as well as the maximum torque, which is 23,000 Newton meters. And if we use the formula of the torsion, then we can plug it all in where it will equal to torsion, allowable shear stress equals to torsion times outer radius over J. J is also known as pi over 2 times this radius to the outer outer shell to the power of 4. As you can see here, when we plug in the values into the system, we can get the C, which is 0.0625 meters. And to get the diameter of the brass, you just have to times 2, and we got 0.125 meter. As well, we can do the same for the aluminum, which we will obtain the value of diameter of 0.109 meters. All right, moving on to question 2, the next question. Okay, for this, okay, so question 5, the solution will be, after we get the values that we don't have and we have, we can plug it into the formula as seen here, whereby torque over J equals to allowable shear over density equals to allowable degree times G over the length. So when plug in all the values, we can find the diameter equals to 0.04 meters. And when we plug in the value to the next consecutive formula, which is this part, we can get the allowable, the maximum shear, which is 4.775 times 10 to the power of 10 pascals. Or we can write it as 47.7 gigapascals. Okay, so now we'll move on to question 7. Song, would you like to explain question 7?
Okay, I will share my screen.
Yes.
Here. Now we got the maximum shear stress is 55 MPa, and when we use this formula, we can get the normal stress Y, and after the calculation, we can get the normal stress Y is equal to 12.48 MPa. And the second question is the corresponding principal stresses. Okay, for this question, we can use we can use this formula to calculate the normal stress P1 and the normal stress P2. And then with the formula, we can got the normal stress P1 is equal to 57.24 MPa, and stress 2 is equal to negative 2.76 MPa. And for about the angle for the normal stress, the delta 2 theta p is equal to about 0.96, and then we turn to the degree, we can get 55 degree, but this is 2 theta, so for 1 theta we can get 27.5 degree. This is for the normal stress 1, and for normal stress 2 we need to plus 90 degrees, so we got 117.5 degree. So the final answer is like that. Okay, so that's my part. Let's turn to the question 8.
Okay, so question number 8. So first we have to define the stresses from first we have to define the stresses. So we can get stress at X by using this equation and then putting in 250 newtons and the area of the cross section, and then we can get 1.67 times 10 to the power of 5 MPa. So we use all of this and then apply it in the stress transformation equation. So we use this equation and then substitute the values for the stresses, and then we can get 1.95 times 10 to the power of 5 MPa for the normal stress. And then for the shear stress, we use this equation and substitute with the stress, and we can get negative 5.37 times 10 to the power of 5 MPa. So that is for the first part. First, we have to find the center. We have to calculate the center of the Mohr circle. So we use this equation, and we just substitute the stress at X and Y divided by 2, and we can get the value, and we can so we get 8.35 times 10 to the power of 5. And then for the radius, we use this equation, substitute the stress, and we can get 8.35 times 10 to the power of 5, and we just need to plot it into the graph, and we can get all the values for the stresses. So that is all for my part.
All right. That is a fair discussion for the questions 3, 5, 7, and 8. I hope the discussion has been informative and we have covered all the bases that we have to cover. And we hope that the video is interesting. Thank you.
Thank you.